Welcome everybody, and thank you for joining us tonight for a storage architecture discussion for media systems. Appreciate the people that are here in person and also online. First off, we'd like to thank our sponsors, Applied, TAG, and GPA. Questions and comments are encouraged and appreciated. We will be monitoring the chat, and the recording of the meeting will be made available on the SMPTE channel afterwards. So, who do we have here tonight? A little bit about our presenter and our panelists. First off, we have Brian Campinotti. Brian is a seasoned entrepreneur and innovator in large-scale unstructured data storage, archiving, and preservation. At cloudfirst.io, he helps global content owners and custodians in developing sustainable, vendor-neutral, and future-proof digital archive strategies and technologies. Previously, Brian was CTO at Front Porch Digital, instrumental in their emergence as a global leader in the digital archive space. Prior to that, he was the founder of MassTech, and he started his career at the CBC. Brian and his team have won 3 Emmy Awards for pivotal innovation in digital archive technologies, long-term digital preservation, and large-scale digital video deployments. He was one of the primary inventors of the SMPTE Archive Exchange format, also known as AXF standard, and holds an electrical engineering degree from the University of Toronto. Welcome, Brian. Next up, we have Brent Engel, managing partner of the engineering and supporting teams with over 25 years of experience in the M&E sector. Brent manages a team that includes engineering support staff and data systems integrators, as well as custom engineering design and software development. He realized early on that the ever-changing standards and formats of manufacturers would create a demand for a higher level of expertise in the implementation of infrastructure to support the networking, workflow, storage, management, and archiving of massive digital files. This would be an important part of the industry's future, and thus began a focused effort to build relationships and partnerships with the key partners and vendors that influence this business sector. Welcome, Brent. And finally, our moderator, Roy. Roy was raised in Creston, BC, and graduated from the Southern Alberta Institute of Technology. He began his career as a maintenance technician working at Canadian broadcast facilities and spent time as chief engineer of Post-Haste Video in Vancouver. In 2014, he began working as a strategic account manager in the US for Grass Valley. Recent roles include VP of Sales North America for Embryonics and VP Sales of the Americas for TAG Video. He currently works for Synesys and lives in Guelph with his wife and son. Come on up, Roy.
All right, thanks and hello everyone. Nobody leaves tonight until we all agree that storage is exciting. Deal? Yeah, maybe you don't need to be convinced. Yeah. All right, so that was the really impressive bios by our panelists. We're really lucky to have 2 people who've dedicated their careers to storage in slightly different ways, complementary ways, dedicated their careers, and they're like over 30. All right, yeah, it is. So my role as moderator, I'm also gonna go through a presentation just as a primer. Some of you are storage experts, but some of you may not work focused in the storage area. So a catch up, a little bit of history. I'll introduce media workflows and the storage ramifications of those workflows and get into technology. And I'm not gonna complete my presentation uninterrupted. I'm gonna go to these guys for comments on certain slides. And please, all of you, jump in anytime. Keep this really interactive. And then after my presentation, we'll do more Q&A, comments, and then Brian's gonna give a presentation as well, okay? So, as I said, now these are gonna repeat some of it, but critique by panelists, critique by you, please critique. and ask questions and ask comments. We've all been to things where someone will say, don't comment, just ask questions. This is not one of those sessions, right? Any comments you have, feel free to make them. So have a good Q&A session. Keep this interactive. All comments and questions welcome. Feel free to interrupt me at any time. Disagreeing is okay, and in fact encouraged. And the panelists, along with their incredible backgrounds, they don't work for a specific storage vendor, right? In their roles, they work with a number of vendors. So that gives them a really great perspective to comment on the space. Also, of course, they're deeply involved with media customers and know that history, and we'll speak to that as well. So company names are mentioned in the context, but we're not endorsing any companies. All right, so my presentation is entitled From Punch Cards to Quantum Storage in 15 Minutes. Okay? It's a big aspiration, I know, but I think I can do it. And I'm starting off with a trivia question, and the winning prize is a Toronto Maple Leafs hat. It's a lovely hat. Nobody's allowed to look at their phones, please. So plus or minus 10 years, in what year were punch cards invented? Just shout out years. 1863. Anybody else? Civil War. Civil War happened in those years. 1947? 1920, 1947? 1890? Anybody else? Nobody's won yet. Yeah. All right, this could go on forever. So I'm going to give it to the lowest year, which was James. And I have you get your speed if you're not a Maple Leafs fan. So punch cards were invented in 1725. Yeah, that surprised me as well. And so the first data storage device, punch cards, used to store sequences for looms, for textile generation. So in 1932, the magnetic drum memory was invented, roughly the size of a human, stored 8.5 kilobytes of digital information. In 1951, the first tape drive was invented, again, roughly the size of a human. And in 1959, the first magnetic disk drive was invented, again, roughly the size of a human. In 1984, flash memory was invented, was not the size of a human. So I've shown the actual human here, the inventor, Fujio Masuoka, who worked for Toshiba at the time. And a slight tangent here, but we're focused on non-volatile storage this evening. There is RAM, there's memory that will be tied in. But a quick tangent regarding the name. We work for SMPTE. It's an organizational body does definitions. The term random access memory means that any content, no matter where it exists on the storage, the time to access it, the access time, is uniform and predictable. So random access means the access is not random. It's predictable. So that definition has always bothered me a little bit. And now it's even worse because solid state storage provides, technically, according to the definition, random access to the content on that storage, right? So companies are generally, tell me if you disagree, generally, I'm seeing more and more they're doing away with that definition and just have volatile storage and non-volatile storage. Right?
I disagree slightly.
Okay.
I would say that usually the way that random is used in that is it doesn't have any.
Oh yeah, Mike. Mike's on, Lawrence?
Check. There we are.
Disagree slightly because I think the intended term, the way it's used in this context, is really compared to some of the earlier forms, especially the tape, where your access had to be in order in a linear fashion.
Sure.
So I think they just meant that basically if it's random, your data is all over the place, you can simply go to the spot wherever it is on the media versus having to go through all of the stuff you don't want to get to the piece. So that's,
Sure.
I think that's how they intended it, if I had to guess.
Makes sense. Okay. All right. Now a bit about, I'll say there are three pillars, the three general types of storage: data tape, spinning disk, hard disk drives, and solid state drives. So cost, relative cost per terabyte. So spinning disk per terabyte, roughly 27 times the cost of data tape, and solid state per terabyte, roughly 100 times the cost of data tape per terabyte. So in 2017, the SSD cost premium over each hard disk drives was 18x, so now it's 5x. So as you'd expected, things getting less expensive. And generally, there's agreement that at 5x the cost premium, SSD is preferred over hard disk drive. But sales of hard disk drives continue at this point to outpace solid state drives. So approximately 80% of storage purchased for data centers is hard disk drive. And SSDs typically use NAND flash memory. Transfer speed in megabytes per second. Runaway winner, SSDs. So significantly faster than tape and hard disk drives. What's maybe a little bit surprising is that tape actually performs decently in transfer speed. Access time is a different story, but in transfer speed, tape performs relatively well. Now in access time in this bar graph, I had to change to a logarithmic scale because the difference is so extreme, right? The access time for tape is measured in seconds. Hard disk drives, it's measured in milliseconds, and solid state drives measured in microseconds. Okay. So IOPS versus throughput. IOPS, input-output operations per second, measures the number of read and write operations a storage device can perform per second, while throughput measures the amount of data transferred in bits or bytes per second. Okay? And in media applications, rendering is considered an IOPS operation, right? You're reading a frame, processing, writing the frame back to storage. So it's considered an IOPS. It's a lot of input, output, a lot of read-write cycles. For media applications, archiving, restoring, content movement, orchestration are throughput-intensive operations from a storage perspective. And what's significant as well, SSDs using the NVMe protocol, they excel in both areas, in IOPS and throughput. Any comments? Good. All right, and relative power consumption, hard disk drives use the most power. And maybe I should make a quick statement in defense of tape. Obviously, if you've got a tape drive, a tape cassette sitting on a shelf, it's not using any power. So this is reference to a tape in a machine, maybe under power and being moved. Noise level, SSDs win, they are the quietest, okay? In 2010, the number of hard disk drives shipped per year peaked. After that year, the number of hard disk drives started dropping. The total exabytes of storage continued to go up, but the number, and that's largely a reflection of the fact that notebook computers started moving from hard drives to solid state drives. Total exabytes shipped by year for SSD is going up at a faster rate than hard disk drives. And SSD capacity as a percentage of hard disk drives and solid state drives is going up and up. So in 2025, this year, roughly 27% of the storage shipped is solid state drives, and in 2026, it is expected to be 32%. So the runaway winner in our performance metrics is the SSD drive, NVMe drive, shown here, the M.2 form factor. So there is as well SSD SATA drives, but runaway winner, the NVMe. So an NVMe drives are a type of solid-state drive SSD that uses the NVMe protocol to communicate with a computer via the PCIe bus, resulting in significantly faster data transfer speeds than traditional SATA SSDs. So winning in speed and performance. There's 1, 2, and 4 lanes that can be used, and 4 lanes is most common. High performance setups and enterprise solutions may use even more, like 8 or 16. So to summarize quickly, many of you know this, I know, but NVMe is the protocol, M.2 is the form factor, and NAND flash memory is the storage medium. PCIe bus speed. So in 2010, PCIe 3 was introduced, and it provided 1 gigabyte per second per lane. And in 2017, PCIe 4 was introduced, and it provided 2 gigabytes per second per lane. And in 2021, PCIe 5 introduced, and it provides 4 gigabytes per second per lane. So incredible speeds being achieved. Now, object storage and block storage. I know this is going to trigger some conversation here. So, and some critique, which is great. So object storage stores data as objects with metadata, offering scalability and cost effectiveness for unstructured data, while block storage stores data as equal size blocks, prioritizing fast access and performance for structured data like databases, as an example. So media applications, object storage, archives, playout, editing, block storage, say your post-production facility, your compositing and finishing, you've got client-attended sessions where you're working with this 8K content, need to access quickly various points in that content, and need incredible access time, short access time, and incredible speed. So block storage, optimal for fast access and low latency applications. Block storage is more expensive. Object storage is optimal for large content libraries. All right, go. Yeah, thanks. Brent?
I disagree a little bit with some of the assertions. Most of the commercially available shipping object storages are, you almost have to think of them as a higher level, a smarter level of storage, just like we would think about programming languages, like comparing a language like Python to assembly language. Most of the commercially available object storages are all running on top of some type of a block storage underneath, which is why when you look at an NVMe drive, when you look at anything Seagate, Western Digital, any of these storage mediums, they're not going to give you the amount of data that it stores in objects, because the data that goes on those devices is still in blocks. So the object storage is an abstraction that runs on the top of that. What it does is it gives you the ability to use that storage with a more modern approach. You can simply put very, very large files or pieces of data, or an object as we call them, by simply using a put and a get. Put the data on there and a get to get it back. I'm sure you have additional take on that as well.
Yeah, I think that is a valid point, but I mean, you can even sort of move that up one layer higher. I think what you probably have sort of ascertained from, Roy's introduction to these different types of technology is that there's probably a fit for all of that in every environment. And really it's finding the right scale and balance of each of those different storage tiers or storage classes across, the needs. So you're not rendering and doing, color correction on an object store or on a data tape, right? You need NVMe, or for rendering and things like that, you need flash-based memory just because of the amount of IOPS that are required. everybody would love to have 50 petabytes of NVMe sitting in their environment, but it's just not practical, right? You're talking tens of millions, if not more, dollars to be able to put in an infrastructure like that. So in much the same way that, Brett was referencing that, down under the hood, there's these different technologies, and it could include even in an object store, flash-based cache as well to get quick transitions or transfers and caching and things like that. Some of them could even use just regular hard drives or SSDs, and then behind the scenes, they might be using something like shingled magnetic recording hard drives, which are much higher density, but don't offer the same utilization characteristics that regular hard drives or SSDs do. So, it's really about finding the magic. And in fact, there's organizations now that have put, an object storage front-end layer on top of data tape as well. So, you're not going to be using that for your day-to-day transactional operations, but it becomes now yet a much easier to manage tier. And I think now and I'll talk about this a little bit in my presentation, is really there's a shift going on away from people caring specifically about the technologies that underlie things. Back, 10 years, 20 years ago, we would all ask, what's the substrate of that data tape, and what's the areal density of the disks, and how many heads does it have, and how much cache does it have, and can it handle this and that? And now it's just, I need something, a service, a piece of software that gives me X megabytes per second in, X megabytes per second out, and I want it to have, you've heard terms like this, 11 nines of resiliency, and I want to be able to access my data within a millisecond or two. And arguably there's smarter people that specialize in this stuff figuring out what the technology behind the scenes needs to be. And if all you see then is an S3 endpoint where you can get input, do you really care what's sitting behind the scenes now, as long as you're getting what you need out of it at the right cost point?
That's the right approach. When we're going into a meeting with our larger broadcasting clients, it's all of these technologies are just tools in the toolbox. And so to Brian's point, we're trying to get people to not focus on the individual buzzwords behind the tools. So we generally start conversations off, what do you want to do? What do you want to do? What do you need to move? What's your workflow? How do you move data around your facility? And but all of these technologies, in most situations, are kind of layered on top of each other. So for most storage devices, we have the block layer, which is the raw flash layer, or it's disk, or tape. And then on top of that, I'm dating myself, but back in the olden days, when I started out, we had video recorders that used to record video as raw data blocks to block devices, because that was the only way you could get, people remember Sierra Design Labs and things like that. That was the only way you could get the data to the disk fast enough. And so there was no file system. But now in most situations, you have raw block devices. You have a file system that's on top of that manages all the inodes of where the data is. And then if you have larger storage, or you have things that need object, then the object layer is on top of that. So it's all just abstraction layers on top of these tools that we call data devices.
Gotcha. Yeah, and I think just the last point on that is what's actually gotten better for everyone is the integration into those devices is much easier now than it was even 5 or 10 years ago.
But it's easier, it's not easy.
Easier.
Yeah. So.
Gotcha. Excellent. Thank you. Great stuff. Anybody else? Any comments from the audience? Good? Okay. All right, now, so that was a lot of bar graphs for a while. Now I'm gonna go over quickly some media workflows. So involving storage, and to begin with, direct attached storage. So the simplest storage solution, one operator, one person, one content creator at one computer, and a storage directly attached to it. Okay, shown here some of the protocols, the connectivity mechanisms: USB, SATA, eSATA, SAS, Thunderbolt. So Thunderbolt 5, now the current and fastest interface for direct attached storage, up to 120 gigabits per second. So, and then moving from DAS to NAS, so network attached storage, now you have a collaborative content creation team all accessing the same storage over network through a network switch, the cost premium per terabyte now goes up approximately 10x. So a 10x cost increase. But there's more value because every terabyte can be accessed by multiple people. So you're adding value as well. All right. And I know we've covered the can of worms, and object storage here is maybe inadequate, but ideally SSD for an editing application, but it could be hard disk drive. And storage area network, now SAN. So again, collaborative editing environment, but now instead of a NAS, it is a SAN. Cost per terabyte premium now is 15x over direct attach, so cost going up from NAS. So this use case where you need incredibly fast speed and quick access time. So again, post-production editing or compositing on 8K content that is client supervised and accessing a large volume of content. And again, acknowledging previous conversation, but typically referred to as block storage on a SAN. And ideally, again, SSD using NVMe drives. Now, cloud storage. So now the content and project files exist in the cloud. Again, it's collaborative workflow, but now you have the ability to be, for your content creation team, to be geographically dispersed. So here shown, the content generation team is spread out at different locations across Canada, all accessing the cloud, content in the cloud, and then working with that content. So now the cost premium per terabyte goes up to 50x compared to direct attached storage. Okay? So a substantial increase. And providers of pure cloud editing solutions, some of them LucidLink, Suite Studio, storage. Now, another way to attack that, to attack a geographically dispersed requirement to access storage, say again across Canada, but is to have that storage in a central location and all of the workstations running applications that access that storage in that same central location, but use VDI virtual desktop to move the UIs out to people. Now you're not moving the content out, you're just moving the UI. Now that provides an efficiency. You don't need a great deal of bandwidth to get to a remote operator when you're just sending the UI, and we can achieve some pretty decent and acceptable latencies that operators can work with. A great deal of documentary films, and in fact news applications, some news applications also use this. Okay? Yeah.
This is very typical of a more modern cloud approach as well. So that storage plus the compute plus the scalable compute, elastic compute could actually be in the cloud, and all of those remote desktops could be effectively anywhere in the world without the organization themselves having to worry about the networking, the infrastructure, the redundancy, the security, et cetera, et cetera.
Yeah, great point. Yeah, thank you, Brian. Great point. Okay, so cost per terabyte now here is less than the pure cloud application as I described it. And now TV news as an application. And so TV news can be a hybrid of all of these things, right? You could be editing on proxy content in the cloud. You could be editing on content that's on a NAS at a central facility and using VDI. You could be, as Brian said, using VDI of content that's in the cloud. You could also, in a news environment, you could be editing locally in a news truck. And hybrid approach, mixing that content, you're editing freshly shot content, mixing it with archive content that's in the cloud or at that central location. So news can bring in all sorts of different ways to attack this, and all of them do exist. And I'll call out Sean Murphy is here from Grass Valley. And Sean, so Grass Valley, other providers, a news system, the Central, Avid, Mimir. I'll also call out Denis Bonneau. So we've got two people who traveled the longest to this meeting, and congratulations, guys. Thank you coming from Montreal. Yeah, appreciate it. Okay, so that's a news applications and the application and the various ways you can attack it from a storage perspective. TV playout, I just included this to make the point that TV playout, the actual playout part used to be.
It's the easy part now.
Yeah, it used to be really, Jeff Bella's here, I remember the Pinnacle sand for playout, right? It was a giant, expensive, enormous sand for playout, right? And now playout, like most storage is kind of yawning when it's playing out content. And in fact, cloud is really general agreement best place to do playout. Okay, and we'll talk more about this maybe with Brian regarding archiving and active archives, but in our new world, more content needs to be stored to enable training of large language models, and archives need to be active to provide AI agents with greater capability. So in today's world, we need to potentially store more content, and that content that is stored potentially needs to be more active and more accessible for AI agents in our kind of evolving world to be able to act on that content and access it. All right, and the bottlenecks. It seems that the history of storage is the history of identifying bottlenecks that in the workflows where you're trying to use storage for media applications. And it's a history of engineering solutions to overcome those bottlenecks, right? So long list of the bottlenecks that historically have been overcome. So storage media speed, interface bandwidth, network limitations, controller performance, CPU performance, software and file system overhead, concurrency and access patterns, data protection mechanisms. All these things have had solutions engineered for them to overcome them. And then now I spoke earlier about NVMe drives using PCIe lanes. Now, in fact, storage vendors, some of the appliances they're providing, they want to put 24 NVMe drives in that chassis, and the motherboards didn't have enough PCIe lanes to support that. So that's been now overcome, and motherboard manufacturers providing motherboards with more PCIe lanes. All right, and then RDMA, now the next bottleneck removal solution, a way to increase storage speed again, RDMA. So remote direct memory access. So allows data to be transferred directly from the memory of one computer to another without involving the CPU or OS on either side. So bypasses unnecessary copying, reducing latency. So no need for CPU to process each packet, offloaded to the network adapters that are designed to support RDMA, zero copy networking, improved energy efficiency, enable scalability. So ideal for media applications where low latency and high throughput are required. And now the protocol used in some of the vendor solutions coming out is NVMe over Fabric /RDMA. Any comments? Would you agree RDMA is a big deal?
It's a big deal. I think that it really is. It opens up the doors to get away from the discrete, bare metal chassis, or even in the cloud having discrete, machines, not virtual machines, but machine instances that you can spin up in the cloud as well. So especially for very, very large rendering projects, very, very large AI projects, that now you can sort of transcend each specific piece of hardware without spending time and resources moving data between extra systems. So I think this has been big, and I'm not totally up to speed on it, but big on the new CBC architecture,
Yeah.
Where they're effectively looking at being able to run, virtual farms on premise, virtual servers in the cloud, and effectively being able to move dynamically jobs up and down, but without having to have a management layer where you're copying things back and forth to do these jobs, where you can sort of, when Olympics comes, they can scale up, and when it's, 6 o'clock news, they can scale back down again dynamically.
I think it's a big deal, but I also think it's more of a future big deal for the majority of our broadcasting clients, especially because right now we have a situation where people that have installed just standard NVMe drives over protocols, they have more back-end bandwidth than we can usually get to the end user servers and clients. So, and with the cost involved, and they already have this performance, the next situation when you upgrade your storage in a facility, I'm talking less about the technology and more about the application of it in real world facilities. But the next step is usually, okay, we have all this really fast storage, but we can't get the bandwidth out to everybody so they can use it. So the next stage is usually budgeting, doing CapEx planning for major network improvements, because usually the network, you have a lot of servers and broadcast workstations, and they've got a 10 gig connection. So we're saturating all of these connectivities that are already in place. So I would say it's important, but I would say in practical, where I see it, where I'm in meetings of people that are planning for 2 or 3 years out, I don't see this as moving the needle in the next year or two, because people already have a surplus of bandwidth that they can't really utilize. The bigger problems are a lot in Brian's world, which is they have all this data they've accumulated. Where are they going to put it? What are they going to do with it? What's the value of it? And then you have the other situation where you have these production storages. They've already delivered an asset. What's the value of that now? It needs to go somewhere else so they can free up the production storage. So we're seeing more just management issues because the storages have gotten so big. Most of our facilities have petabytes and petabytes, and they don't know how to manage it. So I would say in the context of the technology, I would say the practical problems that are right in front of us are those first. So
Excellent. Okay.
being the Debbie Downer, but that's what I see all the time.
No, thank you. Yeah. And yeah, a hand.
So I'm just bringing up the concern about security with RDMA versus on-site cloud, trying to make sure that, and this can be very dangerous, trying to deal with the security aspect of this on a network that you don't have tight control over. It's a huge problem if somebody, starts manipulating data on your RAM. And then, the latency of trying to go through like firewalls and VPNs to try to protect against that. So unless you have like a isolated network, it seems very dangerous as well.
Yeah, I think it's a very valid point. I think most of these environments, even in the environments that we're dealing with that aren't quite using RDMA yet, it's all direct connect, so it's actually dedicated networks. It's not using public internet to scale to cloud anyways. So it's all low latency, dedicated connections. Theoretically, I don't know enough about RDMA to see if encryption could be built into that infrastructure. Probably not, because you probably have to include the CPU at that point. But yes, it's about the right architecture. It's about understanding. But I would argue that probably every single feature production today is done in the cloud at some point during its production life cycle. So I think a lot of those issues are being addressed by the large studios anyways today.
I also think that we have other examples of similar. It's not as fast, but we have storage fabrics that have been using fiber channel protocol for some time. It's not encrypted, and people have used that across facilities on, I think a lot of it has to do with the access. Would you want to use that protocol over the WAN? Probably not, but if you've got a dark fiber that you've lit up between either yourself and a direct connect to a cloud provider, then I think that you're at basically the same level of risk that we already have with fabrics, where you've got raw data. But I can tell you this from being in the business 30 years, I've had plenty of servers that have file level access, that have actual file protocols. Those are usually what's attacked. I can't think of a single time I've had a storage device attacked at the block level. That doesn't seem to be as interesting to hackers. They don't want to try to intercept blocks in flight.
Too complex.
Make sense of it. Yeah, it's easier to grab data that makes sense that may not be encrypted. So, but that's the one parallel I can draw.
Well,
Your question.
you're kind of making the comment about like from that security access, the beauty of tape sitting on a shelf that can't be remotely changed until it's brought into a drive.
Yeah.
Air gap is still something, right?
Yeah.
But we'll cover this a little bit later. It's always a concern about security.
Yeah.
Having all of your assets in one cabinet that's 10 square feet on your data center floor, that could be an area of concern as well, right?
Mm-hmm.
Yeah, I guess another protocol that, like if we're building hybrid environments and we have to move data from on-prem to cloud, we typically will just build IPsec tunnels so that the security happens at the tunnel layer and not necessarily what's flowing through the tunnel. So, but anyway, cybersecurity as a whole, that would be we could have a 5-hour SMPTE meeting on that.
Yes, we could.
So.
Yeah. Okay, and just to make an excellent question, thank you. But and to follow up on Brian's point about the CBC initiative, which is an EBU initiative as well, DMF dynamic. Hopefully, we can do a SMPTE meeting, get somebody in. And I was lucky enough to attend it last week, 2-day seminar. I don't know how it was, but yeah, it's fascinating. And they do have in that their ways, their strategies for security. But it is using RDMA. Gosh, it's something called libfabric I can't speak to, but used in AI systems and ring buffers, replicating content streams in a live production environment using shared memory. It's really, really interesting what they're doing. So we'll hopefully be able to do a meeting on that and get someone in to speak on it. All right, I'm wrapping up the future. Now, future storage technology. So DNA storage. What is I think most fascinating about DNA storage is that all the world's data could be stored in a coffee cup using DNA storage. So incredibly dense storage. Lasts for thousands of years, very low power. It's currently very, very high cost and very slow read-write speeds. With DNA storage, you're actually creating the storage medium as you write to it. It's synthesizing DNA and writing to it. So it's wild stuff. Certainly doesn't seem to be near horizon, but very interesting.
I read a new term, bio-cybersecurity now, where people can actually get involved with the actual synthesis of this DNA to, corrupt it, to plant different things into it as well.
Really?
So
They're called viruses.
yes.
All right, and then holographic storage, very high density, stores data in 3-dimensional space, extremely fast read-write speeds, so better than DNA in that aspect. Lasts for decades, but the cost very, very high, and also doesn't seem to be on the near horizon.
But I went to a SMPTE presentation, a white paper discussion at NAB about probably 20 to 25 years ago. And I was promised holographic storage by this time. I'm still waiting on
There
that.
you go.
Not holding my breath, but I'm waiting on that.
So the latest on it was there was a company called, I can't remember what they were called, 10 or so, 20 years ago maybe, but they spun off their patents. It was acquired by an organization, I think it was called Arconia or something like that. And they
These are
were,
crystals, right?
they had a substrate. It looked like actually like a DVD kind of thing, and they were doing holographic print. It was like a thick DVD, but all of those patents now have been acquired by Apple, and they have, to my knowledge, they have no plans of commercializing it. So not sure about this, but there's offshoots of this. There's a quartz etching one where they have
That's the one I'm.
solid quartz. That was the 3D one like that. So I think all these are great, and there's a few more out there actually, but it just really depends on the time to market. Now maybe we don't care about this today because, tape is still pretty good and the cloud is getting, whatever they're using to store hamsters and spinning wheels or whatever, they're pretty good and it's getting cheaper. But this kind of thing is really, the next leap. Now we're not worried about 5 or 10 years longevity. We're worried about 100 or 1,000 years of longevity. So, it'd be interesting to see what happens in the next 10 or 20 years with this other stuff.
Yeah.
And while we're on that topic, who in the audience knows what the most reliable archive format is so far that we've had ever?
Punch cards.
Film, yes.
Arguably stone tablets. Film hasn't been around, but very, very poor bit density.
Yeah. There's a firm out of Colorado that's actually taking 35 millimeter film, and they're not putting anything that's optically pleasing on it, but it's essentially, they're just putting what looks like microscopic QR codes on it, and they're storing digital information. They're starting to store preservation documents and things like that, because it's really the only proven 100-year, more modern, in addition to the stone tablets. But that what's that? Explain that to us.
Archives.
Oops.
Sorry, the Americans are using it in their archives, and Canada has used it up to a certain point. But now that getting drives and stuff like that for it is difficult. Quantel used it to keep their data for their editing systems.
And the technology was optical, you said?
Magneto, yeah, I believe I'm getting the name right. Magneto-optical, where the laser heats up the surface. The permanently charged magnetic particles orient themselves, and once it cools down, they're permanently locked in.
So it's kind of a combination of like a DVD and a hard drive kind of
Yes.
combined, essentially.
And
Yeah.
that was apparently rated at 99 years.
Well, there's rated, but what I was getting at was that we actually have film that's
Yeah.
been around for 100 years.
So
It may not look that great, but you could still watch it
microfiche.
if it doesn't catch on fire.
There's a lot of technologies, unfortunately, that have come and gone over time. There's an offshoot of that. I think that one's called DOTS, the one that they're printing dots on films, on visual films. There's one that uses a stainless steel substrate, so they're actually chemically or laser etching stainless steel, rolls of stainless steel. So the argument there is now you have heat and radiation resilience as well. All of these are great ideas, and I'm sure there's a million more of them out there. It's just whether they can become commercially viable at scale. That's the question.
It seems like we're still stuck for a while, the last 60 years, at figuring out different ways to glue rust to moving substrates.
Exactly. And rust it properly.
And yes, exactly.
Excellent. All right. And we've arrived at quantum storage. So quantum storage utilizes quantum bits or qubits, which can exist in multiple states simultaneously. The term is superposition, and be interconnected with other qubits, even over long distances. The term is entanglement. This allows for faster and more complex data processing. So extremely high density, exceptionally fast read-write speeds, low power, but still faces numerous technical challenges and still does not seem to be on the near term.
What is I'm familiar with the quantum computing research, but what on the quantum storage what's the medium for this? Is it some type of a semiconductor?
Oh, I don't know.
Okay.
Microsoft just released the first processor, right?
Right. Yeah.
But I think they're still saying it's a decade away from any level of commercial viability. I think the error rates that they're seeing still in quantum compute is actually very timely, because for those of you that still use Skype, it's dying, I think, in about a month. So they've managed to kill that as well, unfortunately.
Right. Yeah. But this, breaks my brain thinking about this and superposition, entanglement, and existing in different places at once, and is wild. Yeah, wild stuff. All right. Thank you. We've arrived from punch cards to quantum storage. That's the introductory presentation. Really good. Thank you for the comments. Thank you for the comments and questions. But that's just the first part of the meeting, okay? And, thank you, thank you. And if you don't think storage is exciting yet, we're gonna keep going and it's gonna get more exciting. We're gonna get even deeper. So maybe as a next step, just first of all, I know you chimed in with great comments and discussions, panelists during that, but anything else you'd like to say in addition, maybe something I didn't include that you'd like to comment on? Anything?
The only thing about just using the storage in a practical setting, you talked about the NAS and the SAN differences. The one thing I would like to add is that what we're seeing now on shipping products is we're seeing storage vendors now shipping products that are both a SAN and a NAS. And an object store, and you simply connect. And a cloud. And it can also interconnect with also software packages that do high-speed data transfer as well. So they've figuring out, it's one thing, you have your storage, somebody else has another storage, and you need to move something to theirs or pull something back. But, so I would say that there's sort of a conversion, and there are products that allow you to basically serve up the data to the people in your organization that need it in the way they need it. If they don't need it as fast, if they don't need the low latency, then you could simply expose a NAS layer to them, and they can simply access files over a file level protocol like SMB or NFS. But if people or other devices need back-end speed, you have a large transcoding farm, and you want to simply connect that over the block layer, then you can put a SAN client on that, and you have that access while other people are simply accessing it. So, and then if you've got a tiering and you've got an object, you can have an object layer, and it can all be the same. And for the most part, going back to the object and file, most people that are using hybrid workflows between on-prem and the cloud, and they're using file systems, it's almost a one-to-one relationship between the file becomes the object and the object becomes the file. So.
Yeah, in fact, not to sort of oversimplify the idea, but what's really changed, to me, is, of course, the underlying technology has evolved. Things have gotten faster, better, denser, cheaper, whatever the metric that you're tracking is. But now you could download in 3 seconds, probably on your phone, a piece of software, open source from the internet, and all of a sudden mount an object store as a file system. You could mount a file system as an object store. You could mount a cloud as a file system. You could do all of this stuff. So it's become a lot easier to integrate versus what it used to be able to drive data effectively to and from a SAN, to and from a tape drive. This was all SCSI block level stuff, very complex. We used to have whatever they were called, shared file systems there with very complex and expensive shared file systems for SANs. All of that kind of, I don't want to say it's irrelevant, because there are still little pockets of it that do fit in the industry. But what's gotten brutally simple is really integrating into all of these different storage types and storage classes and storage services, whether they're on-premise, in the cloud. Effectively, the cloud is a very complex philosophical thing to understand, but effectively you could think of it just as an extension of your own data center, right? So you have a 10 gig network going into your data center that's behind this wall, or you have a 10 gig network going into somebody else's data center that happens to give you a portion of their resources. So, I think that breaking down the barriers through these more ubiquitous interfaces like S3, you've heard of S3. S3 is a storage service from AWS, but more importantly, it's an interface technology, an API. It's a way to get and put things into and query object stores and write metadata. And everybody, more or less, supports that same thing now. So whether you're buying an on-premise object store, you're going to Google, to Microsoft, to AWS, to some tape libraries, they all kind of speak S3. So if you understand how to do that, you can now integrate into all of those things.
It's almost become ubiquitous. When somebody says object store now, they say we're using an object store. It pretty much, the assumption is that you can read or write to that through the S3 protocol. If you would get raised eyebrows if it doesn't support that protocol. So.
And then as Brett mentioned, the funny thing that's still a little bit confusing is that every one of those then has inbuilt software that also exposes an NFS, a CIF share, a block-based if you wanted to get in at that level.
It's just data.
It's just
Share it out and move on with your life.
It's a lot easier today. When in my previous lives, we were developing software to be able to integrate into all these different things that gave us data or things that we put data to. And there was 100 different interfaces and protocols. And every time there was a new, tape drive from Oracle or from IBM, we'd have to bring it into our labs and we'd do a bunch of testing and things like that. Now it's like, does it support S3? Yeah. All right. Standard command set? Yeah. Great. Can you expose an external endpoint that we can test to? Yeah. Click, click, click. Great. Everything works. All right. Certified. Let's go. And it really is that easy.
The complexity is still there, all the stuff that Brian mentioned, but it's been productized and it's mature now. And so performance, we used to have long discussions on a big project with a broadcaster. We would just do analysis on all the stuff and performance, and it was such an issue. We'd just spend days and weeks on it. Now we spend about an hour on the performance. Okay, we got a handle on that. Spend about 2 or 3 days, maybe a week or two, on sizing it, or what size it needs to be. And then the other 2 months are spent on the budget. So it's,
And not one about the actual technology anymore. And that's a really key point, right? People still, purists, care about what's being used behind the scenes, all this different type of stuff. But at the end of the day, as Brett mentioned before, what's your objective? What are you trying to do? Is it a render farm? Is it an archive? Is it a scale out environment for an shared editing environment? Is it a global audience that you need, or is it a localized audience? And all of those sort of help us on the elimination path of what is applicable and what's not applicable. But almost never does it come up. And in fact, most of the cloud vendors don't expose to you what they're using behind the scenes. They tell you, this is how much it costs. This is how fast you can access your data. This is the resiliency. This is how many, erasure codes or replication cycles you have.
durability.
And durability and things like that. And that's it. And if they have, monkeys with chalkboards, if they're using stone tablets, or maybe they're using DNA or whatever, most of us don't know or don't care anymore.
It's very interesting. Yeah. Okay. And from the audience, yeah, hand, excellent. 1 sec for the mic.
So a little bit of a loaded question, but LTO.
Never heard of it.
Never. or equivalent technology. How long do you see that being as relevant as it is now? I mean, even cloud providers have like one called Glacier for moving stuff into tiers of storage, and then also.
But they don't use the T word. It's Glacier class storage. They would never. Tape has a bad word. They don't.
Doesn't matter.
Doesn't matter. We're still gluing Rust to some sort of substrate and putting data on it, and they're managing all that for people, and they make it simple. But we have also on-prem or on the edge or hybrid versions of LTO tape. So for cold storage, there is nothing else that's going to replace it on the cost per petabyte. So it's not going anywhere anytime soon.
Okay, that answer.
Only
Okay.
if you're thinking about just storage, right? So if I said to you, you have a petabyte on premise running on tape, and you want to move that to the cloud, the first question I'd ask you is why? And ultimately, you might be actually moving it from your LTO into their LTO.
Yes.
That you don't have to manage anymore, that you pay a prescribed price for at scale and everything like that. But if all you're doing is you're looking to move the data, then I 100% agree with Brett. Keep it on premise on LTO. It doesn't make any sense to move it. Okay. However, if you are looking at the cloud ecosystem, you're looking at new avenues for AI, if you're looking to do cloud playout, if you're looking to do rendering, things like that, editing in cloud, if you have a global organization and need people to access your data, it changes the conversation significantly. It still will be a premium, like Roy's graphs kind of showed. You'll still pay a premium for it, but the benefits of it, then you have to think of it more holistically than just a storage to storage comparison.
Okay.
The
But I get
other
the
thing
consensus,
that,
you guys both are firm, it's here to stay for the foreseeable future.
yes, and I think both in the cloud, I think that the hyperscalers and the cloud providers are going to continue to use it as a cold storage platform, as a cost-effective, a Glacier tier platform. And then I think the people on-prem, and then I think a lot of organizations want to be cloud agnostic. And so what they'll simply look at is having an on-prem copy on one of these type of erasure-coded tape systems, and then they'll put a secondary copy in their public cloud provider. We're also starting to see that in larger organizations.
I think there's, what we're seeing certainly as a global trend is there's less and less greenfield customers investing in a large on-premise tape infrastructure in media and entertainment. I'll say as a broad swath of the market I know. There's certainly, everybody has one more or less now that they put in, 5, 10, 20 years ago that they keep on maintaining and upgrading and things like that. I think the market has changed. I think, arguably I've never been a tape salesperson, but maybe the tape sales guys used to sell to 1,000 customers each. And now there's 5 customers each, and they're maybe buying more because, the storage is still growing, the requirements for storage. 2 of their customers might be Google and Amazon, and then, a few others here and there. So I think the technology as a sound technology is going to remain. I just question where it's going to be run.
Exactly. And if you're an organization and you're not staffed to handle that kind of thing on-prem, then one of the questions that we ask, and this is true with a lot of our sports broadcasting clients, especially the RSNs, because for most of the content that they have and they need to archive, they don't own the rights to it. So one of the questions I ask is with the executives is what do you want to store? How long do you need to store it? Is this just for compliance reasons? Because even our sports broadcasters, they own the rights to the pre and post game, but they don't own the rights to the content. The leagues own that, but a lot of them are paying to store this stuff. So if they don't have the staff, then a good use case of this Glacier class storage is simply put this in a public cloud, because the cost to put it there is really, really low. If you're not going to access it, if you don't need it that often or ever, but you have to have some sort of compliance, you need to keep it for 7 years, or you might want to go back, or you just don't want to make a decision about all this data and you need to kick the can down the road.
It's that one. Nobody will ever push the delete button, right? So this is another, unfortunately, one of the negative things that tape has caused in a lot of these media organizations is a lack of media management, and even arguably us on our home computers and home networks. Have we ever deleted a photograph? Have we ever deleted a music file or a document that we created in WordPerfect 30 years ago?
You might need that.
You might need that, but so that's the question, that if we ourselves are scared to push that delete button for once and for all, who and what media organization? And we have these conversations all the time when large organizations say we estimate that we have 20% duplication across our archive of maybe the same file with one frame of discrepancy or a different audio track or things like that. And they want to go in and fingerprint all of that data and spend millions of dollars triaging it, or figuring out whether they have the rights to it or don't have the rights to it. We're in conversations with a large sport broadcaster in the US right now that's grappling with that same challenge. And right away, I'll get in front of that and say, find the person that's going to push the delete button first before you dump that money into it, because it's going to be way, way cheaper just to store it in the coldest, darkest, cheapest storage you can. If nobody's going to hit the delete button, than it is to identify all those duplications. And then if nobody touches it in 5 years, maybe by then you'll find the person that's going to hit the delete button.
And it doesn't matter how large the organization, nobody will ever step up and do that, because if your OpEx is out of control and you pushed all the stuff to the cloud, you might get yelled at or scolded for having this large AWS bill, but you won't get fired. But if you delete a bunch of things, it's just somebody happened to want, and an executive finds out, that could get you fired. So that's the reality.
Excellent. Okay. Any other questions or comments or things you think weren't covered in my presentation or the discussion? one sec, Mike, there.
With respect to cloud service providers, everybody talks about, AWS servers, but there's lots of other cloud providers, especially in our parallel, north of our parallel here, that aren't those AWS servers. And so one might ask, well, how reliable are they? And even though you have a contract with them, who's to say that they're actually going to hang on to your valuable content in the way that maybe a big organization like Amazon does?
I'll take that first, and then I'll hand it over to Brian, because I'm sure he has some input. So we call those, once you get past AWS, Google, and Microsoft, we go down to the tier 2 hyperscalers or providers. And we've had one provider, I'm not going to mention names since we're recording this and streaming it out live, but we have one of our providers that had massive data corruption. They had a drive manufacturer that pushed out a firmware. Nobody tested it. All these teams, we just need to push out a new firmware upgrade. You know what happened in the old days of, hey, let's go into the lab and let's test this. They just pushed it out. It created massive data corruption. Some of it they were able to restore, but some of the clients, catastrophic data loss. And if you read these legal agreements, buried in there, there's not really any kind of, sure, you can sue anybody for anything, and we have a very litigious society. But at the end of the day, if they didn't do it, they didn't do it on purpose, and you can't prove that they did it with malice, good luck. So I would say your guarantee is about as good as the quality of that particular tier 2 vendor. And it's that risk itself that keeps a lot of the people, they'll pay the extra money to use AWS and use Google and Microsoft. But that doesn't mean that you've got any better guarantee. So I'm not a lawyer, I won't play one on TV, but I've just been on the integrator side of this and seen it play out. So that's my 2 cents. I'm sure you have a take on this as well.
I tend to agree with it. I kind of think I loop the same thing in with, cyber attacks and that type of thing as well. And it's kind of funny personally, I make a joke about it, but I just want to be less interesting than him, because hopefully they'll attract the attackers more than I will. And I think it's kind of be facetious, of course, but there's a point about, you look at an Amazon or a Google, and the media and entertainment business, although it's the most important thing for all of us, is probably this much of their global business, right? They're protecting. All of your banking information is there, all of your health information is there, all of our security data, all of our terraforms with our friends down south of the border. All of that information is in the cloud in one of those providers today, as it stands right now. So they are investing the most heavily in security. They are investing most heavily in hardware and hardening and testing and doing all this kind of thing, because a small mistake there could be a big mistake across a large, swath of their customer base. So, and again, back to the point I made before, is that, again, if you're just looking to store your data, the tier 2 providers could be fine. Maybe an on-premise tape library is fine. Really, the value of the big players, and I would argue we don't sell or specifically advocate for any cloud provider, but one of the reasons why AWS has been so successful in media and entertainment is they employ almost 700 people specifically dedicated to this industry. They've hired experts from every aspect of every media workflow that you could ever imagine. They have a cloud ecosystem where if you want to spin up a render platform, a transcoder, some of James' kits over there, it's all there in an ecosystem, and you can just kind of click, and try and buy, use as you go, and turn it up and turn it down. Infinite compute, infinite GPU, infinite AI, and everything like that. So it's much more attractive than, and where the tier 2 providers or the private cloud providers lack is that ecosystem, right? You're just looking at it at like the Wasabis and the Backblazes of the world. They're just pure storage providers. So there's a place where that fits. If you are worried about egress and active productions, then maybe that is a good fit.
Or you don't, the situation we talked about earlier, you don't really own any of the data that you're backing up.
Yeah,
so,
or that.
And you're not willing to pay the tier 1 price for it. So it's all risk reward.
It all depends. And the thing is that, because you're not buying an infrastructure, you can change your mind at any point in time, right? You can egress out of a tier 1 into a tier 2, you can egress out of a tier 2 into a tier 1. It's all there, and it's much, much easier when you're not talking about these silos of on-premise data that you have as traditionally typical in these
And
environments.
just a tip for everybody in the room, if you do it on the upfront side and you have a sizable archive, you can negotiate on the upfront side the egress. If you do decide you want to take it out of there, but you better negotiate that on the front end, not on the back side.
Yes, so there are actually all three major providers have now data center presence in Canada. AWS, I think, has 3, Google has 2, Microsoft, I think, has 2. So Calgary, Toronto, Montreal, effectively.
Yeah, it gets a little sketchier in Europe, but that's a different situation.
Yeah, I mean, imagine that, right, in Europe. Yeah, so it's actually, I mean, it's a relevant new conversation because we have been talking to every Canadian broadcaster over the past 7 or 8 years about, migration and what their future looks like and everything like that. And, still, you actually pay more for having your storage here in AWS in Canada than you do in the US, even with the exchange. So it has been historically attractive to say, can we just put it in US East or US Central? And now that conversation is no longer occurring. So now it's more a commercial conversation with the AWS Canada folks saying, we need you to be more aggressive on the pricing. Why isn't it in line with, what it is 100 miles south of here? And we're starting to see those conversations happening today.
Yes, James.
I would just say, just to be clear on the tier 1 providers, thank you. Your Google, your Azure, your Amazon. If you just put your stuff in a bucket without having all the backups and all the other stuff done, and they lose it, because they do sometimes lose that, there's no recourse. That's gone. So either you make sure you have the backups, or you make sure that all the rules are in place to back that up automatically, and then you can have a guarantee of some amount of security even in tier 1.
Gotcha.
Yeah, it's true. But they also do within singular regions, they do actually do, cross data center, not exactly replication, it's called sharding across three different data centers within a region. So your data is not stored in a box in one facility, it's actually shared across multiple chassis, multiple technologies, across multiple facilities as well.
And this is specific to the tier that you're putting it on in the lifecycle policy.
Yes.
All right, and we can do more questions later, but I want to make sure we get to Brian's presentation. So next step, we'll just one moment while I get this set up.
Perfect. I'll give you this in case you want to heckle me. Excellent. So thanks, Roy. I think this has been a great conversation. I may have even learned a thing or two today as well. Never too old to learn, I guess. What I wanted to talk about a little bit was more along the lines of, not specifically about the technologies and the underlying things, but just like what we're seeing in the industry as far as everything back from, like, say, the play to air or the production storage backwards. So all the way back into tape and very, very cold, dark cloud archiving and things like that, and some of the trends that we're seeing in the business. I want to start just actually with a quick survey. So I know there's a few vendors, some couple end customers in there. So how many of you have had experience managing or running or at least seeing large tape robotic systems with arms flying all over the place and things like that? Okay, yeah, most of you. Peter, you were back in the day as well. So it's kind of funny because it's this sort of ongoing question about, the viability of tape. And in fact, right now, today, for the purpose that it serves in these environments of cold archiving, cold/active archiving, tape is still the best technology that there is out there, really. So in the past, you needed, a huge tape library system with a bunch of robotic hands and things like that. And there's a bunch of manufacturers of that. And slowly but surely, every one of those more or less has died out over the past few years. There's a couple remaining, but some of the big players like, Storage Tech and Oracle, they're no longer making the technology. Also on the tape drive side now, there used to be a handful of vendors and manufacturers, different competing technologies. And now effectively it's down really to LTO. I think, is IBM still making the Jaguar drives? No, those are dead too. So all the enterprise class drives, the Storage Tech T10000s, the IBM Jaguars, those are all dead. They've dropped out too. Yeah. So, and then, maybe 6 or 7 years ago when LTO-8 first came out, there was a year patent battle where nobody can get LTO-8 media. And at the same time, all of the vendors, a couple of my previous companies that were sort of building the software to manage those infrastructures, they were going through a flux of acquisitions and rope mergers and things like that. So there was a real question about the sustainability or long-term viability of these types of platforms running on premise. And around that same time, and I think it was just coincidental, was when Amazon announced Glacier as a technology, right? Okay, so how many of those people that had their hands up now, whether you're active in those technologies or now, do you think that in the next 5 years that your organizations will still continue to run those on-premise tape infrastructures? I see a head nodding. Ish. Yes. Yes. All right. All right. So, I think that I made the joke before, but the tape sales guys or the tape library sales guys used to sell to 1,000 or 10,000 customers, and I think the number of those customers are diminishing. There are certainly vendors out there now that the libraries themselves have become much more cost effective. The drives are still, they're still expensive, but not terribly expensive. And the idea is if you have, petabytes of data, it's still a very, very cost effective way to manage the data. There's a ton of complexities around managing those infrastructures. There's a skill set that you need to have experience and knowledge of and everything like that. I would argue that Puritan skill set is diminishing, at least except in large organizations where they have an IT or an infrastructure department that deals with that as well. Some of the vendors are stepping up with additional services to be able to, add advanced spares kits and easy to replace and easy to swap. Some of them are serviceable by the end customer and things like that. So there's changes underway. I think for at least the next 5, my feeling is probably in 5 years, you probably won't be running those tape infrastructures on premise. Certainly if you're facing another capital refresh, if another end of life, end of support of the particular system that you're using, but maybe there's still a place for it in the long term. Sorry, Tony, do you have a question?
Cloud-centric, will they have the same answer to the question?
It's a very, very good point. We get into meetings with, the chief engineers that are my age or older, and we do reminisce about Ampex, and we talk about data tape, and we do all this kind of stuff. And then the 20-year-old rolls in the room, and he's like, what are you guys talking about? So it's a good point. I mean, part of that is a change in the industry as well, right? And if your next big infrastructure project, let's say you are doing a refresh of your plate-to-air systems and you engage with these wonderful folks from Grass Valley to build out your infrastructure, what's the likelihood in 5 years that you're going to be building up a server farm on premise to do that? So then if your workflows are being launched in a cloud or in a private cloud or public cloud, doesn't that inherently mean that probably your content is going to get dragged there as well? And if you're doing cloud production and cloud editing and cloud news distribution, and that's all in the cloud, isn't there going to be a sort of an inertial effect where the content needs to move there? One of our first projects was with Discovery when they did this big deal about 7, 8 years ago with Evertz, right? To do cloud origination of more than 200 channels in 200 different languages across geographies and things like that. So what they did was they started with basically from the viewer, it started moving backwards in the technology. So they took their entire plate air infrastructure and threw it up in the cloud and worked, quite closely with Evertz on some bleeding edge technologies. And quite quickly, they realized that, oh shit, we don't have our content there. So they had all of these on-premise huge tape infrastructures, and one of our first engagements was helping them to migrate that into the cloud, because where they were using it was in the cloud and their content was back on-premise. So they were introducing risk and latencies by having to move things back and forth. So, I think your point is valid. The next generation coming in probably doesn't know or doesn't care about data tape. Actually, in fact, I'll go back to my argument. They won't care about storage technology at all. It's a service. They're looking at it from, how quickly can I access, how durable, what does it cost? That's what they're looking at. They don't care if it's Gophers, punch cards, or DNA storage. It just manages what that looks like. And let's say, some magic thing happens and all of a sudden there is, glacier, I don't know, dinosaur fossilized storage, and that is DNA-based storage, and now it's 1/1000th of a penny per gig per month to store your data. And now all of a sudden, they've leapfrogged on-premise data tape, the complexities, and now they're worried about it. So I think that there's a lot of factors that could factor in, but I would argue that probably in 5 years, it doesn't mean that tape's going to go away. You're just going to be probably paying somebody else to manage that infrastructure and not caring very much about what they're actually storing it on. Okay, so that's a lot of introduction, but one of the terms that I tend to use a lot is about archive transformation. And actually, it's kind of funny that Roy prompted me to this question with his questions that he sent out that he was going to ask today, that he hasn't asked yet, but I'm sure he has them in his back pocket. So what do I mean by archive transformation? So if I talk to you about migration, if you have, let's say, your photos on your home computer or on a direct attached storage drive, and I tell you, do you want to migrate that to the cloud? What does that mean? Probably it means to you that you're going to, I don't know, open up some browser interface or drag and drop something and just sit there and watch the progress bar quick, slowly moving. And once it's done, if you didn't get any errors, then your migration is successful and you can move on. But when we're talking about the crown jewels of an organization, there's much more to a migration than just the data and the file copy. So, first of all, it's the scale of the data. We're involved with some migrations that are 40 or 50 petabytes. And even on multiple 10 gig direct connects on the fastest compute, the fastest tape technology, the fastest servers to the fastest tier 1 cloud providers, we're still looking in excess of 2 years to handle the migration. Because one of the key things is that these organizations still have a business to run, right? So they're still using that infrastructure day to day. They have, emergencies, they have elections, they have, sporting heroes dying, and they have to go in there and drag content out of their archive. So the scale of the data is in the petabytes range, which is, gigabytes, 1,000 gigabytes, terabyte, 1,000 terabytes, petabyte, and, we're dealing in the tens of petabytes in terms of scale. Roy actually he mentioned something that was quite important, is that, even though SSD and all these different, flash and solid state memory devices are very, very fast. In fact, tape is very, very fast because it scales very well, right? Each tape drive can move maybe 300 megabytes per second in and out, and then you can just keep on adding tape drives until you can basically saturate any network or any infrastructure that you want. But it is linear, as Brett alluded to, so you can only be reading or writing to one device at a time. You have to go through to sequence. So time to first byte of access is in the order of minutes versus the random access stuff of the other technologies. Sensitive legacy archive infrastructure. In some cases, we're migrating off of LTO2 and LTO3 technologies. This is 15 or 20-year-old infrastructures, right? That the customer hasn't upgraded. They only have one copy of everything. So, when we touch a data tape, we want to be very careful and touch it once, only get everything off that we possibly can before we have a problem. So, if all of a sudden you just sort of dragged and dropped all of the content, and we've had customers try to do this without realizing that, alphabetically doesn't mean that the stuff is stored in that order, and so that all of a sudden all their tapes are getting loaded into drives and they're copying one file off of each of them. So it could be a disaster. Preservation, this is something that we unfortunately don't think of, and this has always been sort of a pet peeve of mine, that we'll go in to talk to, the Disneys of the world, and they're arguing with us about spending I don't know, $500,000 to put a second robot at a different facility to replicate their content geographically diversified and everything like that. And they're arguing that they don't want to spend that. And this is like, the origination, the 4K scans of the original Snow White films and things like that. I'm using Disney, but they're actually one of the better examples, but every other broadcaster is about the same. And yet they go off and they spend millions of dollars on email backups and database backup software and services to do all of that. And it's just like, but is that more important? Like your organization can exist without email, but it can't exist without your content, right? Your assets. So digital preservation is an important thing as well. And this is part of that, it's more than just a file drag and drop copy, right? You want to authenticate the data. You want to make sure that every bit here is every bit there. In some systems, it actually was able to capture just a hash or a checksum at the time of archive, so dating back 10 or 15 or 20 years ago. And if we can validate that all the way through its entire migration lifecycle to the end target, it's a pretty good guarantee to the customer that the data is valid and is reusable. And what you don't want to do is find out 5 years down the line after you've put away your tape robot system, destroyed your tapes, or decommissioned that infrastructure, that you have a bunch of corrupt content that you've been paying 5 years to store in some cloud service that is not accessible. This is one that really we didn't touch on today, but the risks of vendor lock-in. So, the tape technology, of course, it's somewhat proprietary because it's a physical media. There was a big push about 10 years ago by IBM to come up with what they call LTFS, which is basically it makes a tape operate like a file system. So you can load it in a separate drive and then kind of drag and drop stuff in and out of it. So most of the archive management software systems that are still in use today still rely on LTFS, and it gives the customer just some kind of guarantee that if that software goes away or gets corrupted, that they can pull the tapes and kind of drag and drop and re-index all that. It's not quite that simple when you have 10,000 tapes to deal with, but or if it's yeah, that's another thing. If you were taking that extra step of encrypting your data on the data tapes, then you're really in trouble because it's pretty good encryption. And then the software itself introduces some proprietary naming and organization of the data on the tape libraries, and would argue that even that software now that has the capability to connect into the cloud and manage on-premise object store, does it make sense to continue to have things stored in an more open environment like a cloud and have it named and organized in a proprietary fashion by some proprietary software that needs to continue to run for you to have the sort of keys to the vault of your archive? So what we're arguing is that part of this archive transformation is about removing all the proprietary wrappers, removing the proprietary interfaces, and effectively giving you pure assets in your on-premise object store, pure assets in your cloud, pure assets in a hybrid type fashion, that now all of these systems that have the ability to speak S3 can directly manage. So now your MAM system, your media supply chain, where the most important information that you have about your assets, the metadata, the contract data, what production it's part of, can directly connect into your physical assets as well. The two next ones, opportunity for asset scrubbing and asset discovery, these are important ones as well. So all of the stuff that's been accumulated in your archive over the past 10 or 20 years came from different versions of Grass Valley, different versions of Avid, different versions of Omnion, Pinnacle servers, whatever else. So you have this mix of different formats of content, different wrappers, different generations of MXF, and different media formats and things like that. So it's an opportunity for you to look holistically at your archive to say, okay, can we federate all of this, use some software tools, maybe to rewrap everything into one more standardized MXF OP1A. We have a customer now that has a huge 9 petabytes of GXF content, which is now no longer supported and not accessible. And we're working with them now to rewrap that into MXF OP1A in flight as we're migrating the data. And then the same thing for asset discovery. And this doesn't mean, throwing all this AI tools at it, but it's really about pulling all the metadata and information that you know about that content, generating some maybe technical metadata, mining some metadata, how many audio tracks, time codes, bit rates, things like that. And all of that metadata flowing along with the content now in an immutable fashion. So putting it into these cloud and object stores that support metadata, why not directly attach the metadata to the assets themselves, really? And then from there, as Roy alluded to before, once you have that content online in one of these newer systems or services, throwing AI tools at it now becomes trivial, where it's just not possible with the tape sitting on a shelf in a robot today. Did you have a question, Roy? Oh. And then one of the bigger things is that, sure, you can look at your archive migration as just a storage migration, and we can handle all of that. But what talks to your archive? What uses it on a daily basis? Your editors are plugged in there. Your plate air servers are plugged in there. Your newsroom system's plugged in there. So all of those have to change too as part of this larger plan. Doesn't mean it has to change, the day that you start the migration. But over the 1 or 2 years of the migration, of course, you want to start looking at what upgrades, what replacements you have to do on your MAM system to now make it smart enough and have the capability to be able to effectively manage these new storage silos or storage technologies that you're deploying. And then, of course, you have to sustain the operation during this whole entire process. And what we always say is that, you can dedicate 1 or 2 of your technical staff to watching a migration and trying to do all these right things, but shouldn't they be doing something that's a little bit more core to the business than worrying about a migration where they're not actually experts? And then the last piece is about this financial impact, right? So all these are kind of technical and operational issues, but at the end of the day, if it's going to cost you 100 times more than what data tape does today, well, let's not even start this whole entire process, right? So being able to look at that effectively before you start down the path of an archive transformation journey is a very, very important thing. And this is really why we came to this terminology. This is really about this holistic view of what this looks like in terms of these types of complex environments. And really, an archive transformation is much more than a migration in itself. And then what we really try to think about and message to our customers is that this is a paradigm shift away from the status quo, right? It's easy to continue to leave that infrastructure in place because it's probably not the biggest priority that you have now. But when you are facing a large capital refresh of that infrastructure, if your software vendor is end of lifing or end of supporting the software, if you have to do a major upgrade or a migration of those, now's the time to think about it, because it's not like we can do that overnight. It might take you a year or more to be able to handle this. So what we want to try to do is look at what that drop dead is and back time and start the conversation today so that we're prepared when that time comes. So you baited me into this before, but this is my is tape dead slide. And not really, because I need to be the good guy. But really what it is there are trends that we're seeing in the industry. So we're working on projects all over the globe now, and people are migrating away from data tape generally. And it's not just necessarily as a slight to data tape, it's still because there's a bigger strategy at play, right? They're looking at cloud playout, they're looking at cloud editing, at global collaboration across multiple facilities that they have. So there's a larger play here where they're not just looking at it storage to storage, it's really about opening up this cloud ecosystem. And part of it is about the sustainability of the software platforms and the complexity of those software platforms that manage these tape archive systems today. I mentioned this a couple of times, is really this idea that these middleware solutions, we would argue that they're no longer necessary, because the higher level systems, the smart systems that know about your inventory, know about your contracts, know about your rights, know about your metadata, have direct interface into your users, they now can directly orchestrate over the storage. So every major MAM system, every major media supply chain system, most editing platforms, tools, all now have the capabilities of plugging into S3. And once they have that capability, because all the complexities of the technology now are abstracted by that S3 software layer, it becomes very easy for those systems to manage even multiple tiers of storage across multiple facilities. It's just different S3 endpoints. And then, I've certainly touched on this a few times. Really, the conversations we had 10 years ago about archiving in customer environments is much different today. Nobody seems to care so much, maybe except in this room, about the tape and the bit density and the aerial density of the disks and the, how many heads and what interface type and things like that anymore. They're looking at it in terms of storage SLA. So all those things I alluded to before: durability of content, resiliency, the 11 nines that you'll hear often quoted with cloud vendors, the uptime, time to first byte, depending on the storage class and things like that, and ultimately how those map to cost. Those are the metrics that we care about now, and how the cloud vendor is storing the data actually doesn't matter very much anymore to anybody. We all have our photos from our phone stored in a cloud service, and we're not calling them up saying, is that SSD or spinning disk or shingled magnetic recorded, whatever. It just gets done for us. And there's a good thing about that, right? They are, and I'm not only a cloud advocate. You'll see a lot of the environments that we're dealing with now are hybrid as a step into pure cloud, maybe in another 5 or 10 years. But they are hiring the best security people. They have, thousands and thousands of the best experts in technology and stored resiliency. They have the ears of the IBMs of the world. They have the ears of the drive manufacturers, the SSD manufacturers. They're the big broadcaster of old days that used to, be able to dictate to Sony what kind of plugs they're putting in the back of their videotape machines. Those are now the cloud providers and cloud vendors. And, in general, they have our best interest at the forefront, maybe not always, but, in general, that's what we're seeing. So some friendly warnings just before you embark on this sort of, archive or storage transformation journey is migrations will absolutely take longer than you ever believe it. And whether that's, the complexities of the lead up, usually it's because it's not the most pressing issue, it just keeps on getting kicked down the path. But, the truth of the matter is that all of these infrastructures have a finite timeline, whether it's the data tape, the robot, the software, the infrastructure that runs on it, the people that you have that knows how to manage it. There's a timeline that's, 1 year, 5 years out, whatever the timeline happens to be. What we're trying to do and message to the industry is let's start the conversation today. It doesn't mean you have to start doing something today, but once we know kind of roughly what the timeline is based on your infrastructure, the technology, what you're hoping to accomplish, where you're looking to migrate, it helps us to better prepare you for the inevitability of the sort of, oh no, we have to spend another $500,000 to refresh this infrastructure. And maybe that's the right thing to do, but it's better to analyze it now before you need to make that investment. And then again, the scale of data, of course. It's very important. It's not an all or nothing conversation. Like I mentioned, some of the migrations that we work on, I'd say half of them, the second after we're done, they smash their tape libraries and throw the tapes into the ocean. Half of them are planning to keep on running it indefinitely, effectively letting it age out of the environment as time goes on. And it's a nice safety net to have, right? You have this infrastructure you keep on maintaining. But now what we can do is we can say, okay, you are maintaining 2 copies across 2 different systems and 2 different geographies. We migrate 1 copy into cold, dark, cheap cloud. Let's collapse those 2 infrastructures into one. Let's pick the best of the tape drives and the tapes and the servers and everything, and then degrade your systems only maintaining 1 copy on premise, because now your archive SLA is spread across your public cloud provider and your on premise. So it's a nice safety blanket, but now we've drastically reduced the operational costs and the CapEx on that infrastructure, and they have now the benefit of being able to consider cloud for all the future projects and future workflows that they're looking to launch. But it doesn't have to be an all or nothing conversation. It could be an and. And just because we're called cloud first doesn't mean cloud only. Don't try to boil the ocean. So all of these conversations we've had the same conversations with a dozen customers or 100 customers about, we don't know what we have the rights to, we have duplications of content, we're concerned about egress costs, we can't do it because of this, this, and this. We've heard it all. We have an enterprise MEM project underway, we have to do this, we have to do that. It's just a bunch of things that we try to filter down into what the customers or what the client or what the organization is trying to accomplish, and try to keep them focused on that part of the project, not on fixing everything all in one fell swoop, right? We're fixing really one problem plus opening the doors to a bunch of other things that they could have the capabilities of in the future. Don't panic, but start planning now, but where to start. So we believe very heavily, and we've seen a lot of proof of this, is data empowerment is key. 100% of the time, I guarantee all of you are wrong about the way that you think you use your organization uses your archive. So we really believe about taking a big step at the beginning of these engagements to really figure out how the customer uses their archive, and proving it using their own data, right? Not coming with these philosophical TCOs and talk about this, we're going to cut 4 heads and we're going to do this, and it's not the reality of these environments, right? But everybody does typically try to build their archive transformation strategy on guesswork and assumptions, and of course that could be dangerous. Typical vendor provided TCOs are inaccurate. I don't know if you guys have ever asked AWS to build you a TCO of moving your archive to the cloud, but they're laughable, right? Well, you're going to replace your tape library once every 5 years. Nope. You're going to migrate every 3 years of tape. Nope. Keep on going. So you just discount. You're going to say, you spend this much on energy. Nope. You have 5 people managing. Nope. Those are all sunk costs. So you just keep on going down this list, and they're kind of laughable. But we're big proponents of making data-driven decisions, being able to help and work with the customers to empower their data-driven decisions. And really, once you have this in black and white, and it could show you once you've done this assessment of your, and this could be done, we have customers that do it themselves. We can help you, open up a spreadsheet and try to figure the stuff out yourself. But we believe that it's important to do this upfront, especially if you're looking at cloud, right? Because what you don't want to find out is that, you miscalculated, and now it's, 10x to your CFO per month that you have to pay into the AWS coffers, and it's a non-starter. But it's better to know that upfront in a spreadsheet than once you start getting your bills. So why consider an archive transformation? I think it really has to do with everything that Roy talked about, everything that Brett talked about, is there are new technologies out there that might serve you better than the technologies that you have. It's not to say that there's anything wrong with what you're running, but really a lot of those systems now that have the ability to manage, like these archive software vendors that have the ability to scale to cloud, well, effectively you're paying a tax to access that same asset that your MAM system can directly talk to. And again, you're continuing to put things through a proprietary pipeline where at the end, even if you decommission your on-premise tape archive, you're still running this archive system to be able to access your cloud, and you have to migrate again once you want to get out of that infrastructure later on. Avoid vendor lock-in. That's a big thing about this, is really, this is an opportunity for you to reinvent your organization, start thinking a little bit differently, and if you plan this properly, you have this opportunity to escape. Doesn't mean, again, you could continue to run that infrastructure for the next 10 years. It doesn't mean you have to turn it off, but at least now you have replicated data, some untethered and decoupled, and some, as it's been in the past, still feeding your existing workflows. This generally embrace the cloud evolution is really about the benefits of being able to launch different workflows and different use cases in the cloud, looking at, you have to transcode a bunch of data maybe to feed your AI guys. Well, why not click a button in the cloud and let, spin up an Amazon service and let it do, or Google or whatever it happens to be, versus, buying 10 or 20 servers that you're going to use for 2 months and then do what with. So it's really a different thought. It's an opportunity for organizations to really look at a different paradigm about their new next generation workflows. This is a big one to us as well, is about enabling intelligent storage orchestration. So, in the past, you had the MAM system with all this rich metadata about these assets and proxies and some contextual knowledge, and maybe some of them even had some AI tools at the time. Naming a file statically and then sending a command to another system, an archive system, to say, okay, store this data in the archive. And then it had rules that said, okay, this is this type of content, so I'm going to make 1 copy here and 1 copy there. But then it was kind of like it's always an arm's length relationship. And really about these archives is there's a ton of wealth in those archives that probably not many customers know about. And by making it more accessible, tying it more closely to your user-facing systems, enriching them with this metadata, you have this ability to do archive discovery that just hasn't been possible in the past. And then the last piece is remaining focused on your core business. Do you want to dedicate 2 or 3 people to the next 2 or 3 years of doing this haphazard file-based migration, or should you rely on partners and experts in a particular field? And just an interesting point, I'm not going to go into this at all, but we just finished a 30 petabyte migration for the BBC, and this was really the whole gamut. We helped them with an analysis up front. They had 2 systems, one in London and one in Glasgow. we migrated, they had done an internal assessment. They came back with basically 3 years, and it was going to cost them 2 or 3 million more over 5 years to migrate to the cloud. They brought us in, we analyzed their environment. We told them that we could do the migration in less than a year, and in fact saved them $1 million over 5 years. And we finished the migration in 11 months, and we got them down a path where we took the two systems, collapsed them into one, reduced it to one copy on premise. So they're still running an on-premise tape infrastructure, and now they have all of this content in AWS, in this case, replicated into AWS. And now all of their workflows, they're spinning up a new MAM, it's going to be in the cloud. They're spinning up new production and editing, it's going to be in the cloud. So it opens up a lot of opportunity for them. All right, so that was kind of it. So sorry about a little bit of salesy stuff there, but it was really about this whole concept of archive transformation and picking the right storage technology, storage SLAs to serve the purposes that you want, and not necessarily worrying so much about whether it's on tape or disk or object storage or whatever else. We can help with all of that, of course. We have that type of experience, but it's really about what your objectives are and what you're hoping to accomplish. Thank you.
Thank you, Brian. And pardon me for 1 second. I'll just get this back where we were. All right. So, and we want to be mindful of time. We were scheduled to end at 9. We're arriving at. Have we convinced everybody that storage is exciting? Yeah, all right. All
They look
right.
riveted.
What's that?
They're riveted.
Riveted. Yes. Yeah. Yeah. Excellent. Any additional questions, comments from the audience? Anything? Questions for Brian about his presentation? Again, any subject we haven't talked about that you'd like to ask about? I am loaded, as Brian said, I'm loaded with questions myself, but I don't want to go too long here.
If we were to just go back in the challenges of storage, we can go back into early days of the beginnings of film. We could actually take those pieces of film out and we could display them. There was some mechanism, some machine that we could put it on and we could display it. We then, look at the music. We could still actually hear Elvis's voice on those recordings. There's a mechanism to do it. But I recently encountered, a sad fact. We got to the 90s and we couldn't find the machines or any of the technologies to actually recover what we had in the 90s. It was all digital. So, realistically, now everything's digital. We always had this point in terms of our creative material and everything that was created in our culture that we would hang on it and it would be there. But realistically, is that really not something we can expect going into the future? And should we really be looking at it from that point of view of really what do we really need, and how long can we really hang on to it?
Yeah, it's a good question. And in fact, we're in a proper venue for this kind of conversation because that's really where SMPTE has been key over the decades or generations with standards, right? So ultimately, arguably, if you created something using a SMPTE standard 20, 30 years ago, you could reproduce or access that data today. It's actually a bigger question that you have because everything that even my presentation about this archive is only from digital data forward. But still, there's millions and millions of film and videotape assets sitting on shelves, decaying with machines that are no longer accessible. There's organizations that build businesses now, Memnon and Perfect Memory and a bunch of others that are looking to help out with this. If you think the TCO analysis of an archive, pure digital archive transformation is difficult, try going back into a a film or a videotape archive that's 100 years old and they have 1 million hours of linear content that needs to be digitized, it's an insurmountable thing. And unfortunately, every single day, week, month, year, that there's decades of data that's no longer going to be accessible, mostly on videotape formats, but then arguably nitride films, that's been a big thing. Decaying films and canisters and moldy warehouses and things like that.
But to his point, there were in the 90s and the early 2000s, we had a lot of really cool television programs that were all still stored on quad, black and white and color quad. And so we had lots of clients at that time converting all of that stuff over to digibeta at the time. And then now some of those digibetas, people pull them off and they want to do a restoration and they can't get a tape deck to play it back without a bunch of errors in it. So to his point, it's that the technology that actually handles the media is it almost needs to be archived and preserved like the media.
I think the Library of Congress does do that. I'm not sure if the equivalent's happening here at Library and Archives Canada, but they do actually warehouse some of the technologies as well in hopes that it will be salvageable. The challenge back then is that, to digitize a 1 hour film or videotape probably took you an hour and a half of human labor sitting in front of it. Hopefully now with the advent of digital technology, we can copy a 1 hour file in 5 seconds or something like that. That will continue to do this. But we had, let's say, not necessarily as significant of an issue, but we have customers that are running LTO2 and LTO3, 10, 15 years out of support, never been upgraded, dusty environments, and maybe not accessible. So maybe another argument for storing in cloud or managed providers, because it's their obligation to continually keep current on technology to make sure that your data is accessible. But yeah, the legacy formats is a tough nut to crack.
I would say another important issue, and you brought it up in your presentation, is I think it's real important to have geographically dispersed copies of these treasured, since we're in the media, films and audio. Is everybody aware of the big fire that happened in Universal Music Group a long time ago? I mean, there were masters that were they're lost, period. So they're actually, you can go to Apple and you can get the high-res losses, but a lot of this stuff is just basically the best they can get off of the discs, off the master discs, that have already been used to make molds, and there's only so much quality on those plates. And so having copies of your archive in different places, just in case the whole building burns down, is important.
Right, anyone else? 9 o'clock as well. Maybe just one more question, and then we'll roll into the wrap up. But we haven't talked a lot tonight about the role of orchestration and MAM systems in handling stored content and maybe moving it to the appropriate SLA storage technology area. So the role of MAM systems in a storage environment for media systems. Speak to that.
I'll speak just briefly on it. I mean, we could do an entire 3-hour SMPTE meeting on just orchestration alone, and then Brian could do another 4 on top of that. So, but I would just say that it's very important. As these systems have gotten to where, as he said, you're focused more on the SLA or what it can do for you, how it can serve your organization, and less important about the technology. Orchestration has become important, not just from the archive standpoint, but from also just managing processes around the storage. We're taking all sorts of broadcast processes. It's not just about the data. It's also controlling systems. We're working on one with the sports leagues, where we want to take all these operations that send out all these Python programs that control a bunch of Evertz equipment. We're putting that into orchestration. That's going into the same system that's also deciding, after these shows come off a Dreamcatcher, then this copy gets sent over here. The metadata is extracted and a copy goes over here. All that's happening through an independent orchestration system. So you're tying all these systems together. I mean, like I said, we could go into a very in-depth conversation on just orchestration, but I'm
Yeah.
gonna let Brian also answer from his perspective.
Yeah, I think that's exactly right. And I think what's one of the benefits now of moving away from this sort of arm's length management of your assets is you do have capabilities like that, right? So I mean, a MAM system or a media supply chain or an inventory system knows the value of an asset more than anybody else, right, in the organization. So if that system can directly decide, you know, whether it's 2 copies, 3 copies, whether it needs to be at 2 different cloud providers, 2 different geographies, where it's going to be consumed next, what's the schedule coming up, you can manage these long access time storage layers that are much more cost effective in a much more meaningful way. You know, it's less applicable, you know, like Glacier Deep Archive, for example, right? It's 6 to 12 hours to first byte of data, but you could bring back a 20 petabyte archive in that same 6 to 12 hours. So, you know, we try to throw the baby out with the bathwater, but there's places for that as well, right? From a disaster recovery perspective, because I would argue that if your tape library got flooded, it's going to take you weeks, if not months, to get access to your data again, even if you have a secondary copy sitting out at Iron Mountain or something like that. So being able to leverage the right storage class and the right storage tier and the right geography at the right time, there's no static policies that could ever be defined in an archive system that could intelligently do that. But if you bring that management up to the layer that knows your business, knows your operation, knows who's consuming that data, it becomes much more possible. And even having, we've seen them, cost dashboards, right? This asset is costing you X dollars per day, per month, per week, per year to store in these classes. You know, do you want us to degrade it down a level?
And these orchestration systems, in addition to all the things Brian just said, I think from my standpoint, when we meet with the clients and when we implement these, there's just as much value in having a single pane of glass where you can go to monitor all this stuff. Because a lot of these things that Brian mentioned, you could have 8 different pieces of software, or we could just script it and run those scripts on 8 different softwares. But having a single place where you can monitor actually what's going on, no matter what type of it is. And now that most modern software has APIs, your orchestration platform becomes your one tool where you can communicate via all the APIs and also have a dashboard and monitor what's going on at any given time. So it's very critical, and it's a pretty deep topic on its own. So.
Excellent. All right. So I mentioned Sean and Denis coming from Montreal, traveling for the system. Brent also flew in from Jersey. So
Yes.
I would have to test which is further.
Porter Airlines. Yeah, baby. It's a bus with wings.
But Brian and Brent, thank you so much. This is fantastic discussion. Thank you to all of you for the questions. And yeah, really, 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 storage is exciting. Storage is exciting. Thank you so much. And I'm gonna turn it over to Tony to wrap it up.
Yes, thanks very much. Jamie, do you want to do the honors before I start chatting away?
Why don't you speak to this and I'll just hand it to you.
Okay, cool. So Jamie's handing out some certificates, the manual kind. If you want the digital kind, just let Roy know and we'll get you a digital kind. Cool. Just a couple of things on closing. You might have gotten an email from SMPTE if you're a member that we're in an election process. So please do vote, because there are prizes from home office. There is you can win a free virtual course. You can win a registration to MTS, which is the fall conference. A membership dues can be paid for a year. There's a merch package. I have no idea what that is. Maybe a mouse pad, color bars, and a mouse pad, sorry. On the home office front, we've got new people at the table. Richard Welch is our new president. He's taking over from Bernard Jenkins. Richard comes from Deluxe. He's the Senior Vice President of Innovation over at Deluxe UK. Paul Steckley, who is local, is still the Finance VP. Sally Ann D'Amato is the new Executive Director, And they're all fitting into their holes nicely. And if you're going to NEB and you have time on your hands, go visit the booth. It is number 5L, sorry, 9, NL5. I don't know where N. What's that? No, it says number sign.
That's north lower.
North lower.
North lower.
5. So they're booth number 5 on the north lower. That's at the back of the bus. And next month's meeting, which is April the 23rd, is going to be for an NEB wrap-up. Do we still need presenters, Nathan? We're doing okay? Okay. If anybody is going to NEB and has a moment or two to present as well, do reach out to us. And then if there's a seat available, we'll let you know. But it is at AWS. We had it there last year, and it is York Street, 7th floor or 8th floor, something like that. And then May's meeting is cloud-based, if I'm not mistaken, and it's going to be at U of T. Oh, it's there. Thank you. And June, we're going to try and do the barbecue. We haven't yet signed on to that yet, but we're working on that. And then we've got September is, October is,
Bit of,
we're working on it.
yeah, but HTML-based graphics is the planned meeting for September.
Perfect.
Yeah, and working on a few other things as well.
Cool. So if you're not doing anything afterwards when we wrap here, there is a group of us going to the 3 breweries, which is Dundas Square South, Yonge Street, 275 Yonge Street, the old Q107 building. Just south of that? Ah, is that Q107? Okay, and I think that's the last. Yes. Applied Electronics and Tag Systems. And if there's anybody in the crowd that feels the urge that they want to sponsor SMPTE Toronto, please reach out. Cool. And thanks to Denis and Rasvaldo for coming down. That's it.
Before, maybe I should have asked this before, but before, did we have any questions from the virtual? No, none, okay. Excellent, okay.
Two comments, no questions.
All right.
And one was a guess, which was way off on your.
So there's no dispute on the actual winner, excellent.
So
excellent.
Sean and Denis, if you're staying in town, I think you are staying in town tonight, do drop by for a beer. Cool, thanks everybody.
Yeah.